are times where I already have the code written out because I want to explain it and kind of go over my thought process. Because I did have to, bang my head against some walls. I mean, this Fibonacci sequence, and this is something that I found online, and it's page 78, number 16. But this part right here, I don't understand yet because this is obviously zero assigned to A and 1 is assigned to B. But if I break these up and just do B is assigned to A and then A plus B is assigned to B, in either order, we don't get the same output, the same response. So I don't understand that yet. I don't understand the list and the commas and all that stuff as well yet, obviously, because and I just feel like, well, I already looked it up, which I really shouldn't be doing anyways, but it was a long time I was going over this stuff, and I just wanted to see if there was anything that was in my vein of what I already know, being an early sort of CS student, with some background, but not a lot of background. I just want to do, what I know. So I know a little bit about list. We worked on this in chapter 3. And you can append objects at the end. And I looked on, SO, and so here's what I did. I defined a function Fibonacci. The argument of that function is IDX for index. It's not really the index. It's really index minus 1. But we'll just call it, we should actually change the number because it's kind of confusing. It's not really an index. It's the nth term. That's probably it. If the nth term is 1, then we return 1. If the nth term is 2, because remember, it's not the index. So it's just a little bit more reader friendly. So if the nth term is 1, which they're going to punch in the nth term, which is going to be greater than or equal to 1, because in the problem it says if you punch in 6, you're going to get 8 as an output. Well, the index 6 is actually going to be 13. It's actually going to be 1 past that. But the book says 6 should output 8. The user input of 6 should output 8. Okay, so I got to fix this. So that's why it's not the index, the IDX. So I'm going to change this to nth term, just to make it really clear. And then so if nth is 1, return 1. If nth is 2, then return 1. Right? And we don't have to officially say that it's, that they're part of list. We're just returning those values. And then here is where we create a loop that basically appends all the other numbers after the 1 and the 1. So for x in range 3 starting at 3, nth plus 1, right? Which was inclusive when you do the plus 1. So it's from 3, let's say nth is 6. So it's going to be from 3 to 7, right? Start and then stop. Start is 3, stop is 7. So it's going to actually stop at 6 because it's going to be 1 minus the stop number, right? Then this loops over and over and over again from 3, 4, 5, 6, or actually, yeah, 3, 4, 5, 6. And we're going to list.append, and this is what we're going to append is list of x minus 2 plus list of x minus 3. Why? Because this is not the index. We're actually going back an extra 1. Because the nth term is not going to be 0. They're not punching in the index. They're punching in the nth term. So instead of x minus 1 plus list of x minus 1 plus list of x minus 2, it's going to be list of x minus 2 plus list of x minus 3. So, and I'll show what I mean when I run it. And then we're going to return list of x minus 1 because it actually returns the 7th. So the index of 7 is actually going to be an input value of 6, right? Which is going to output 8. Excuse me, an index of 5, right, is going to be an nth value of 6, right? Because it's going to go from the actual index is going to start at 0. So we're going to go 0, 1, 2, 3, 4, 5, right? Well, that's 6 digits. So if instead of punching in 0, we're letting them know, hey, the nth term starts at 1, not 0. It's not the computer science number that they're punching in, that computer scientists use for their work. It's just, a user saying, hey, I want to know who came in first, or I want to know who. It's all about who was first. So then we have to move everything back 1. So then we're going to return list of x minus 1. So it's a little bit tricky, actually. So let's see how it works. So I'm going to close this. Close this. Let's open idle again. The shell. Flip 2. All right, I think it should work. Okay, let's start with the nth term. Okay, the first term is 1. Right, we run again. Now the second term is going to be what? 1, right? It's 1, 1. Yeah, that was our if and our elif. And now is our loop. Now we're going to do the third term. Third term is going to be 1 plus 1, which is going to be 2. Right, now we run 4. Now it's going to be 3, right? Because 2 plus 1 is 3. Now, let's make this fun. So for all of these, we're going to return the updated list. So we're going to keep updating the list. We're going to keep returning the list every single time. Actually, we're not going to return it. We're going to print it. Let's print it. Let's print the whole list, because then we're going to see, as it's updating, it's updating too. So for each one, we're going to print the entire list. And let's run it. Actually, let me just show you the big program right here. Okay, so let's make sure the nth and nth and x minus 2 plus x minus 3, x minus 1. We're okay on parentheses, I believe. Yeah, so then we go here, and this here. All right, so now let's X out of this, kill it, and then we'll run it again. So here we go. So now let's do 10. Boom. Okay, let's see how we did it. This is the first nth term, second nth term, third nth term. So it starts at 3, right? Remember, it starts at 3. Our loop starts at 3. It starts right here. So it goes from 3 and then nth plus 1. Well, our nth is 10. That's what we punched in here. The argument gets passed through this parameter. This is our function header. Fibonacci is our function name. And then we run it through all of these steps one at a time. So this loop is going to keep running. So it starts at 3, ends at 10, right? So 3, 4, 5, 6, 7, 8, 9, 10. So this is 3. So if someone punched in a 3, that's what would spit out, right? If someone punched in 4, that's what would spit out. If someone punched in 5, that's what would spit out. And let's see if they're adding up right. Yep, 1 plus 1 plus 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. Keep going here. Keep going there. Keep going there. Keep going there. Bang. I like it. So I really find this to be of tremendous value, like printing this list. Let's run it again. Let's run it and pick 6, which is the example in the book. It should output what? 8. Yes, which is what we do. We output 8. So it goes here, and then here, and then here, and then here. It prints out the whole list as it's updated, as it's going through the loop. This is going to be 3, 4, 5, 6. Right? And it's going to go, and then this is our 6. So 3, 4, 5, 6. The 6th term. 3, 4, 5, 6. It's actually the 5th, the index of 5, but it's the 6th term. That's why it comes out 8. So yeah, we want to follow the instructions of the assignment. even though it's a little bit confusing because we're used to, if it was a different version, maybe the book would have been written, more computer science index type of request. But they're thinking like a user, right? The user doesn't say, "Oh, this is first. We'll call it 0." That's a computer scientist thing. So we've got to cater to the user if this is going to be an actual application. And so we want to just make it clear in our explanation here, in our print statement, the nth term, right? The first term, second term. We're not going to say the 0 term, the first term. So we had to figure it out. So it's this here, the x minus 2 and the x minus 3 and the x minus 1. Makes it a little bit easier. We could obviously put comments here to explain all that. But yeah, hopefully this was helpful. And we did do lists in chapter 3 here. I might be a little bit ahead in terms of the append, but I'm pretty sure that it would be sufficient and fall underneath acceptable work for this chapter. But that's the key also, right? Is to see how much ahead you're allowed to go, you're allowed to use in terms of creating this code for this question. Anyways, hope this helps. Thanks a lot.